Okay guys, we have another example. The example is a 5-foot ladder is leaning against a wall. So I have shown here a ladder. Let me say, give the name to this red line, which is ladder, and the length of the ladder is 5 foot, leaning against the wall. So here we have the wall, the ladder is leaning against it. It slips in such a way that its base is moving away from the wall at the rate of 2 feet per second at the instant when the base is 4 feet from the wall. So here I can give the name x-axis or base. Here is the floor of the wall, and here is the perpendicular, which is the wall, we can say. So wall is presenting as y-axis and the floor is presenting with x-axis, and it says that the base is moving from the wall at a rate of 2 feet per second at the instance when the base is 4 feet from the wall. So when it is 4 feet from the wall, it will start moving. How fast is the top of the ladder moving down the wall at that instant? So first of all, let me define some terms. Let t is equal to time per second when the ladder starts moving. When the ladder starts moving, let's say y is the distance from the top of the ladder to the floor. Y is equal to distance from the top of the ladder, from here, top of the ladder to the floor. From the top of the ladder to the floor. Let x is the distance from the base of the ladder. X is equal to the distance from the base of the ladder to the wall. So what is given here? Given that when x is equal to 4, the base is moving away from the wall. It means when x is equal to 4, the base is moving from the wall. The base starts moving from the wall at the rate of 2 feet, which is given here, at the rate of 2 feet. 2 feet per second. So it means that the base starts moving when x is equal to 4. It moves at the rate of 2 feet per second. We can write down here the rate of change in the base of the ladder with respect to time. The rate of change the base of the ladder with respect to time when x is equal to 4 is equal to 2 feet per second. And what we're going to find, how fast is the top of the ladder moving down the wall at that instant? It means we need to find the rate of change in the distance from the top of the ladder to the floor. The rate of change of distance from the top of the ladder to the floor, this distance. We need to find this distance and the rate of change of this distance when x is equal to 4. It means we need to find dy by dt with respect to time when x is equal to 4. When x is equal to 4, we need to find this. So from the figure, what we can do, from the figure we can easily find the Pythagoras theorem, because the hypotenuse, which is the length of the ladder, is given 5 feet. So we can say by Pythagoras theorem, square of base plus perpendicular square is equal to the hypotenuse square. Here we have hypotenuse 5, so 5 square. X square plus y square is equal to 25. Let me give the name to this equation number, and also I want to give name to this. Let me say here equation number 1 and equation number 2. So we need to find dy by dt. So I am going to differentiate equation number 2 with respect to t. Differentiating equation number 2 with respect to the time t. So I'm going to take d by dt on both sides of the equation 2. So d by dt of x square plus y square is equal to d by dt of 25. So first we need to take the derivative of x square then y square. So x square is equal to 2x, and by chain rule the derivative of x will be dx by dt, because we are taking the derivative with respect to the time. So 2y dy by dt. The derivative of constant is equal to 0. So as we need to find dy by dt when x is equal to 2, when x is equal to 4, we need to arrange the things so we can easily find dy by dt. So the terms which don't have dy by dt, we will take it to the right side of the equality. So 2y dy by dt is equal to minus 2x dx by dt. So now we can take 2y to the right side and it will be the denominator of minus 2x. So dy by dt is equal to minus 2x by 2y dx by dt. So from here 2 and 2 will be cancelled, and we can write here minus x by y dx by dt, which is dy by dt. So here if we see equation number 1, dx by dt is already given when x is equal to 4. So what I need to do, I need to find the value of x and y. X is given when x is equal to 4. If I put the value of x is equal to 4 in equation 2, I can get the value of y. So I can put the value of x and y together in equation 3. So I am going to say find corresponding values. I can easily find the corresponding values. We can find the corresponding value of y when x is equal to 4 by putting x is equal to 4 in equation 2. So I'm going to use this equation. Put x is equal to 4 here, so it will be 4 square plus y square is equal to 25. 4 square is equal to 16. Let me take 16 on the right side of the equation. So 25 minus 16 is equal to 9. So y will be 3. Taking square root on both sides, we will get y is equal to 3. So if we have x is equal to 4, we have y is equal to 3. So I'm going to use these values of x and y in equation 3. So we can get dy by dt. Put x is equal to 4 and y is equal to 3 in equation 3. If I put x is equal to 4, we have already given that dx by dt is equal to 2 feet when x is equal to 4. So I can also put the value of dx by dt when x is equal to 4, which is equal to 2. So I can put the value of dx by dt also together with the values of x and y. So dy by dt when x is equal to 4 will be, so x is equal to 4, y is equal to 3. So dx by dt is equal to 2, which is equal to 4 2s are 8 minus 8 by 3 feet per second. So the top of the ladder will move downwards to the floor of the ball at the rate of minus 8 by 3 feet per second.